Hey, I'm Kyle Grossmiller, and I'm a Cloud Solutions Engineer at Pure Storage.
Hi, my name is Adam Mazuz, and I'm a Cloud Solution Engineer as well.
In today's session, we're going to talk about Pure Cloud Block Store's architecture on Azure, and we're actually going to break it up into a couple of components. First, Adam will talk about some of the networking and other generic requirements that are needed in order to stand up a Cloud Block Store instance. And then we'll switch over to me, and I'll talk about some of the actual native Azure offerings and components that make up a Pure Cloud Block Store solution on Azure.
In order to deploy Pure Cloud Block Store in Azure, there is a couple of requirements that you have to meet before you start deploying. The first requirement, you need to go and check the list of supported regions that we have Cloud Block Store is supported within. The second thing you should do is you go and create a resource group in that region. Within the resource group, which is a container that holds all the Azure resources and services within, you create a virtual network or a VNet. The VNet should have 4 subnets that the Cloud Block Store then will require to deploy its services to or connect the controllers, which is Kyle's gonna explain later on. The 4 subnets will be management, replication, iSCSI for the storage traffic, and the last one is the system network. The system network has to have a couple of other requirements, which we need to make sure that it has an outbound internet connection. And in order to do that, or the simplified way is to use a NAT gateway. So you have to connect that NAT gateway to the system subnet, and then the NAT gateway would make sure that you can have an outbound access to the internet, where we use that for phoning home, and also during the deployment, the CBS or the Cloud Block Store has to go through the internet to register its licensing into Pure One. So this is a very important requirements you have to meet. The second requirement for the system subnet is to connect it to 2 services within Azure. Those 2 services, and the reason why we have these 2 services within the VNet is because we need the connectivity to stay within the network of Azure backbone. Those 2 are the Cosmos DB, where all the metadata of our CBS infrastructure will be stored at. The second endpoint service you have to do is the Key Vault, which where the encryption keys for Cloud Block Stores will be stored. An optional endpoint service that you can connect to a replication network is that the Microsoft.storage, which if you would like to use CloudSnap with Cloud Block Store. Now I'm going to turn it back to Kyle, where he's going to be explaining to us what other native services the Cloud Block Store will be deploying within this resource group.
Hey, Kyle here. Now that Adam has gone through the underlying requirements that need to be in place in order to deploy Cloud Block Store, I'm going to walk you through the mechanism by which an end user would actually go through to deploy it. It starts over here. You have your cloud administrator who connects into the Azure Marketplace. If you search for Pure Cloud Block Store, you'll see it there. It's an item that's fully deployable from the marketplace. Optionally, we also have a Terraform provider for deployments as well. But let's just say for this example, the customer is kicking it off through the Azure GUI marketplace. When they kick off a Pure Cloud Block Store deployment, there's a few fields you fill out: what region, what resource group, what VNet, what subnets for that VNet do I want to use for each Cloud Block Store service, license keys, alert emails, all those sorts of things. Availability zones are filled out during that deployment template. And when you do that, it kicks off an ARM template. And that ARM template will deploy a managed application inside of your resource group. And that managed application is comprised of a few different things. Notably, we have 2 different Azure-based controller VMs, VM1 and VM2. These represent our two purity controller VMs. Those of you who are familiar with the on-premises FlashArray are aware it's a dual controller architecture, and Cloud Block Store is no different. So those two controller VMs are stood up and are representative. It's basically the SaaSification of an on-premises FlashArray. And those two controller VMs are running the same purity code base that we run in an on-premises FlashArray. So common REST APIs, common user experience for what you're used to in an on-premises world. We have two different controller VM types. I believe they're D32S and D64S. That will probably change soon. But that's basically a V10 and a V20. And there's different performance tiers and capabilities, and obviously cost associated from an underlying Azure resource perspective, depending on what SKU you choose as a customer. In addition to those two controller VMs, we also set up two Ultra SSDs here, and those serve as our NVRAM modules. NVRAM is where writes are acknowledged back to a host that you've connected up to the Cloud Block Store instance. It's also where we do things like pattern removal, compression, encryption, all that good stuff. And then eventually we stage that data down to additional Ultra SSDs. There's 14 in all, which serves as our persistence layer. And so those 14 Ultra SSDs have multiple capacity points. We start with a certain provisioned amount, but over time, as the Cloud Block Store array fills up, you're able to non-disruptively increase that Ultra SSD size and get bigger as necessary. It's also worth noting that these two controller VMs connect up to the 4 different VNets that Adam went through earlier. And that's actually how Cloud Block Store communicates out to the outside internet, as well as to native Azure services over something, for example, like your iSCSI connection. Thank you very much for watching. That covers our architecture and underlying components of Pure Cloud Block Store. Please stay tuned for a lot more great content.